I'm sure we've seen some of these formulas at some point, whether it's the sum of numbers from 1 to n, the sum of squares, or the sum of cubes. But where the heck do these formulas come from? Usually in math classes we prove this using something called induction, which requires a lot of calculation and is boring. So today we'll be providing visual proofs to these sums. Okay, let's start with the first sum, the sum of integers. This is what we're trying to prove. We're going to do that by drawing 1, 2, all the way to n squares this way, each square of area 1. In our case, n equals 4. Notice that if we draw those squares in reverse, like this, we obtain a perfect rectangle of height n plus 1 and of width n. So the area of that rectangle is n times n plus 1, and since we have 2 times the amount of rectangles we need, we can conclude that the sum of integers from 1 to n is n times n plus 1 divided by 2. Alright, sum number 2, the sum of squares. Here's what we're trying to prove. We're going to prove it by drawing each squared number with a squared figure of the same area. So here's for 1 squared, 2 squared, 3 squared, and 4 squared. The color codes will come in handy later. Now what we're going to do is peel off the yellow layer from 4 square and arrange it this way. Then we do the same for the pink layers 4 square and 3 squared. Then the green layers for 4 squared, 3 squared, and 2 squared. And finally the remaining white squares. So we have our sum of squares rearranged this way, looking like a tower. What we're going to do is take our original squares and attach it to a tower, like so. Now look at that. With 3 times the sum of our squares, we obtain another rectangle. Let's compute its area. Well, its height is 1 plus 2 plus 3 all the way till n, which we know now is n times n plus 1 divided by 2. What about the length? Well, it's going to be 1 plus this length here, which is 4, which is also our n, plus this length here, which is 1 less than 4, so it will be n minus 1, plus our remaining 1 over here. So if we add all those together, we get 2n plus 1. If we multiply the length times width, we get 3 times the sum of the squares, which is the area of the rectangle, right? So we can conclude that the sum of the squares is this. Right, now sum number 3, the sum of cubes. Here's the formula we're trying to prove. Again, we're going to try to visualize our cubes, but because we want to keep things in 2 dimensions, we're going to break down our cubes this way. First, 1 cubed is just 1, so we just have 1 square for it. But 2 cubed is 2 times 2 squared, so we draw 2 squares, each of area 2 squared. We do the same thing for 3 cubed, which is 3 times 3 squared, and then 4 cubed, which is 4 times 4 squared. Now we're going to rearrange our squares like so. For the first square, we just copy and paste. For the 2's, we take the first square and break it into 2 halves, and rearrange each half like so. We then fill in the remaining square. For the 3, we copy and paste as well. Now for the 4's, we do the same thing as the 2's, which is we break the first square into halves and move each half to the corner like so. And then we fill in with the remaining squares. We're going to stop at 4 to keep things simple, but you can imagine that to extend this, for odd numbers we just copy and paste, and for even numbers we break the first square into 2, and then we fill in the corners, and then fill up the rest with remaining squares. So our final figure is a square of side 1 plus 2 all the way till n, which we know to be n times n plus 1 divided by 2. And just to make sure, the height is going to be 1 plus 2 all the way till n as well, which is n times n plus 1 divided by 2. So the sum of cubes is the area of the square, which is n times n plus 1 divided by 2 all squared, and we obtain our desired formula. Thanks for watching. If you learned something new through this video, please like and subscribe, and be sure to click the notification bell as well. And drop any suggestion or clarification questions in the comments. Thank you and bye.